So yesterday's session on land cover and land use change, I think, was a lot of fun. I learned a lot. And it was clear that we now do monitoring and modeling on all scales, really from the plot level to the regional scale to the global one, which is also what we need to really get at both the biogeochemical cycles and the effects of, in particular, land use change on the biophysical pathways. And I thank everyone for participating yesterday, and Brice and I, we've spoken a lot to what people think should be part of the summary, but still it's probably pretty subjective. But this is why we have the discussion afterwards. So, over to you first.
Okay, so on the monitoring aspect, we talked about cross-product synthesis coming out now. For instance, there was this presentation from Valerio Abitabile trying to fuse biomass maps. It's an ongoing project. We heard about the land cover CCI project from Pierre de Fourny as well. They are about to release these global land cover maps. And interesting is they were specifically developed for the climate modeling community. So it shows, in fact, this project, beyond producing maps and data, shows successful interactions between the different communities. So that, yeah, the modelers can get not only data, but data specifically designed and appropriate for their own needs. And then, yes, I would cite this very same project that facilitated the development crosswalk between the land cover legends, the classical legends you find on these maps, and with the PFTs as well. I remember, I was not there at that time, but I remember that these meetings were rather it was a bit complicated at the beginning because people were using the same words but with different definitions. At the beginning, the interaction was complicated, and so they made this effort, and at the end, they were successful in their project. So this is something that is very needed: closer collaboration and harmonization, standardizations in the methods, but as well in the vocabulary. High quality regional land cover classifications, yes, we have that already. So we can achieve land cover classification with a high accuracy at the regional scale. There are successful initiatives, for instance, for forest inventories using LiDAR, for instance, in Scandinavia. They are using LiDAR professionally now. There are other studies more at the local level, notably in tropical countries. You probably know the RED+ program that aims at mitigating deforestation, forest degradation. It's not operational yet. Everything is airborne, but we are moving towards this. A few global land cover maps at high resolution. Higher resolution, let's say 30 meter Landsat scale, have been released already. Well, they are the pioneers, so they are discovering all the issues regarding the development of such big maps. But we are, the accuracy is not as good as we would like, but it's coming step by step. So it's not operational yet, but you can see the trend. And yeah, the data availability for now exceeds model capabilities. To go back again, what I know the most, the ISA land cover CCI initiative, I know that Brockman Consult, this German company, has been in charge of the pre-processing of the images, MERIS data, and I know to produce these global land cover maps, they've been running their algorithms for weeks and even a few months. So it's still very, very long. But when you want to update the pre-processing, the correction, atmospheric corrections, etc., it still takes a lot of time. And yeah, the availability of data, the archives are more and more open and available. from 2008, the Landsat archive is accessible. Some of you may know that already. It has been in the news for a few days now. Spot Image is going to provide spot data for free, so you can get data back to 1986, but the images will have to be 5 years old at least. So that's good news. It will happen sometime this year. I don't know exactly when, but this is good news as well. ESA announced as well, I think it was in December, that the European countries agreed to apply a free and open access data policy on the Sentinel data as well. So this is good news, but yeah, still we've got a lot of data, but in terms of capabilities, I mean, yeah, the processing, yeah, I mean, there's still some improvements needed.
So what I see as the main results from the session on the modeling side is in the way that we started to implement land use change, I don't know, some 10 years ago or so. The next new thing now is really moving beyond that towards land management, and a couple of groups are working that. That includes forest management, that detailed crop models are now implemented, really earth system models, irrigation is accounted for, herbivores are much better represented. And this will bring up all more issues on the next slide when we talk about what the next steps might be. Also, although models still are coarse when they work on the regional or global scale, there's more and more moving towards substrate scale land use change processes being represented. For example, within a grid cell, we have fractional coverage of PFTs, but we can even represent that at the same time as a forest is being cleared for agriculture in the same grid cell, part of the agricultural land is abandoned and regrowth such as happens with shifting cultivation a lot. And this is something that in the current IPCC simulations is accounted for by a couple of models, but by far not by all. But there's a trend towards such processes. I also found, in particular from our poster session, that the modeling community is moving beyond the standard variables that we cared about for the last few years. So usually we looked at climate, carbon, at the ecosystem state. But now there's more integrated measures, like, well, they're mostly related to ecosystem services like biodiversity or species composition that can also be now be used instead of PFTs in models, or also these integrated greenhouse gas values that we've seen posters about. And this is also possibly something where the monitoring community could kind of try to think about if these variables aren't such that if they can be provided by monitoring, as well as the climate and the carbon variables can be represented. On several instances, we came across these fake uncertainties that are totally unnecessary, and there's this moving towards reducing these. Ben's talk that Jens also mentioned before was moving toward that, really use one data set in all the biosphere models, and then you can really get at the model differences. And also this land use flux definition issue goes into this same realm. And what Brice said about data availability exceeding model capabilities, so this is true for some aspects. But the other way around is also true for other aspects. So that the models are capable of handling irrigation, so some of them are, or can represent herbivory, but we don't often have the data sets that we would really need. And this again comes up on the next slide very much of what specifically the modeling community might ask from the monitoring one. So to get at this integration of the monitoring and modeling, what we found, what a strong message from this session was that there is now communication that is successful between those two communities. You see that with the essential climate variables and with the land cover, since this is the first variable really being provided, you see it's a big success. And Brice showed in his poster that it's really the monitoring community seeks to get at these different requirements for the different communities, and this could, in the end, also lead to recommendations of which data set is appropriate for this task as compared to the others. What I found was that the global Earth observation data, not just remote sensing, but also inventories and ground truth, is used foremost in two aspects in the modeling community. The one is clearly we need some input like land cover, forest age, distribution. And we also need Earth observation data for evaluation of the model, and it's being used for that quite a bit, biomass, phenology. But what I missed a bit was that we don't really try to derive process understanding at a level that is directly relevant to the global modeling community. So I think there's a lack that could be easily bridged with all the data available at this moment. So I guess this brings me to the open scientific questions and possible recommendations. So the first goes more towards the land cover change that we've worked on for a decade now, but where there's still open questions, and the second then to the land management, and then I hand over to Brice again. So I think we're still missing some crucial information on implementing land cover change in our regional or global PGVMs. Just some examples. So it has become clear that even if you provide exactly the same map, people start to implement it in different ways. So this crosswalking to the model-specific PFTs, this was one issue. And this was a similar result really also to the Lucid study, where they also found just saying which cropland and pasture extent you have isn't enough, because then people will start to think about how that matches their specific model requirements. And there's programs moving in that direction. LAC foresees one in the LUMIP, which is the preparation for the CNIP6, the IPCC simulations, is also thinking about how to really constrain the uncertainties by being as specific as possible in terms of land cover input data. But this, of course, brings problems with it, because if you prescribe one specific way, this is not necessarily the one that's correct, because we simply don't know the truth sufficiently well from monitoring. The allocation is another big issue. I'm speaking here of allocation of when we have the information of how much cropland or pasture extent there is, from which natural vegetation type do you take it in your model? This is usually not prescribed by the Earth observation data. But we could probably go to very high resolution and get this information, because at very high resolution we know it has been a forest cleared for cropland in this spritzer and not the grassland. And this is really important. This really matters a lot for the carbon cycle. Degradation has come up several times, and I'm wondering, the models would probably be capable of capturing some of these carbon emissions from the degradation, but we don't have the data available at the global scale that could feed directly into our system models. And then we've seen that there's the move towards new PFTs, bioenergy is one aspect, and towards species level. And also on this, the CCI now has a land cover data set, but I'm wondering if this couldn't be extended to species level or to also include these new PFTs. On the land management side, which as I I see as the next big thing that most DGVMs will move to, we need more information on the subgrid scale growth transitions. We've got all these new processes, irrigations, wood and crop harvest, what happens to the residues. We have local evidence, it's mostly anecdotes, but I'm wondering how we can scale this up, combine that with the global remote sensing maps and inventories to get a better grasp on how we can deal with this. And this is one issue where I think there's a lot more inventory-based data available as is currently being used, because the modeling community can't do the synthesis as well as the Earth observation community could do. But only the modeling community really knows that they have these needs. Another issue is the land use intensities, like grazing intensities. So I think what would be required is that the modeling community really comes up with their wish list in a very clear way, and then we can see which data is available and where synthesis is needed. And also then, I mentioned that this ecosystem service going beyond these standard climate and carbon cycle variables. I guess there's more information in the Earth observation community on directly evaluating such variables as is currently being used. Please.
So regarding the time series analysis. We've seen some examples during the presentations and in the posters as well. So here we are still at the, I would say, it's not operational yet. There are a few algorithms. I may mention the BFAST algorithm developed by Jan Verbeselt, was present here this week. So, for instance, to stay on this example, it's available on R, so you can understand that it's not too fast for now, it's not operational, but we are progressing on this. For instance, I know that Jan is interacting with Google to implement on the cloud his algorithm, so one may expect to have something more operational. Even we could think about downloading automatically the images from the archives, the newly acquired ones, and run automatically these change detection methods. So, but we are not there yet, so it brings back to a previous topic regarding the availability, the capacity to process the data. So yes, it's crucial for modelers, but for other communities as well. I mean, I mentioned briefly the RED Plus method, the RED Plus mechanism. And yeah, I mean, people have to report on the activity that is on the ground. So it's not just for modeling, but it's just for reporting what's happening, and all these conventions still under negotiation at the international level to reduce the greenhouse gas emissions. So there's a lot of user communities there, and they are all pushing for more operational activities for change detection. Of course, there are as well initiatives to go back in time. For instance, Pierre de Fourny, I think, announced this, or at least informally during this week, but the ISA Vancouver CCI Phase 2 will start in March. And one of the tasks, the objectives in the Phase 2 is to produce other global Vancouver maps going back in the 90s. So, of course, it will not be made with MERIS data, probably with AVHR data, but yeah, I mean, this is going to happen in the next few years. We have a longer time series for Vancouver at a global scale. Now, talking about the harmonization of regional data sets, I mean, I'll speak more familiar with, but it applies to the regional scale as well. For instance, Professor Martin Herold, which is from Wageningen University, has been involved in the development of the Vancouver classification system. Now it's a standard, international standard, developed by the FAO, notably, and it allows the harmonization, or at least to understand what's exactly represented by the legend in the Vancouver maps, and you allow a translation across the maps, so you allow inter-comparisons. So here we are talking again about standardization, harmonization, to allow within the Vancouver community, but beyond with the modelers, to better understand what's represented, what we are talking about. Just to take this example, the forest. I mean, there's one well-known definition of forest. The FAO has provided one, but still, it gives some flexibility to the people to adapt their own definition to their local circumstances. So we are talking about forest cover density, minimum mapping area, height at maturity. So here you need as well, it's another concept at GovSeagull. I'm the GovSeagull Vancouver project officer. We've been advocating for the transparency. And when you release some data, you need to be transparent and explain exactly what you have done. And for instance, when we are talking about quality checks, here you need to mention, for instance, for the reference data, the confidence of the interpreter, the expert, in the result or the information in his interpretation. You should provide that. I mean, we've been advocating this for a few years now, people are catching up a bit, but it's still not the case for everybody. So, yeah.
Okay, I think we have Clay, so we should move to a short discussion. Okay, so it's open. It's very short, it's pretty good.
You can say something if you want.
Only a short comment about the process level, which was criticized. We at the ESA, we are actually doing a different kind of project. We're doing operational projects, like. So I have to go closer. Okay. We at ESA are doing different kind of missions. We are doing operational missions, which we are doing in cooperation with UNICEF, for instance, or in cooperation with the European Commission, like the Sentinel missions. But do not forget, we have a dedicated science program, which we call the Living Planet program, which is in particular looking into process understanding. And there's dedicated missions coming along which are meant for the science community to get a better understanding of process level.
I have a brief question on the land cover data types. You listed the degradation of land, the point, but there is also now a substantial trend in the abandoned land, kind of recreational land or land which is the natural ecosystem goes in the direction of restoration. So is it interesting to monitor and to see what's going on this part of land?
Well, definitely, we know from the local studies that for a carbon cycle it matters. So I think, yeah, we should specifically put that on the list as well.
Concerning land management and forests, I would also add that there are also other communities which are working for many years on this. So this is the forestry community. So every country in Europe, for example, tries to get an overview about every 10 years or every 5 years over the state of the forest. So there's important knowledge in these studies which could be used for your attempts.
Yeah, I fully agree with that. I think why modelers are a bit hesitant is most of us work on the large regional or mostly even on the global scale. And the modelers don't have the capacities, they don't have the knowledge to integrate 100 different forestry products to get the global picture. It needn't be global, but at least a large enough spatial scale. So in North America or Europe, that's well covered, but there's a whole lot of the rest of the world. And maybe we're just not aware of what data exists at that level. But then this may be more an issue of communication rather than creating the data set per se. But you're totally right that all these inventory-based estimates, they should go directly, be upscaled with remote sensing and feed into the modeling.
I wonder a bit what is really the relation between the modeling communities and the remote sensing communities. If you say, Michael, that there are initiatives to understand the processes behind the data that we are seeing, it looks to me a bit that there's somehow a one-sided activity and not a dual-sided activity. And this conference was a bit in the attempt to really confront the people from the modeling side, even from the ecological, from the trade-based side, immediately with the remote sensing community. But I do not see. I think that was a good idea, but I do not see really a kind of mechanism that brings these things together. For instance, I'm trying to understand what the time scales in the system. That is one thing that is very important in future for us, for understanding how the land processes are acting. Yeah? I think like finding out for things like mortality in the biological system, the recovery from disturbances and things like that. That can be done only in a strong cooperation between these communities, but there is no real mechanism of bringing these communities together.
I may just mention there are project-specific initiatives, like within even not just the line cover CCI, but within the entire CCI, beyond the line cover. I mean, I forgot the name, but there are some specific mechanism to facilitate and make this communication